Hello, Sandeep. Good evening.
Good evening.
Am I audible and visible?
Yes, ma'am.
Okay, thanks. Let's wait for 5 minutes. Let's see if others are joining. We will begin shortly.
Okay.
Okay, let us start. Good evening, all. Welcome to live session 7 on NPTEL Natural Language Processing course. I'll just share my screen. So, I hope my screen is visible to you. Just a sec. Please confirm if the screen is visible.
Yes, ma'am.
So today there is this live session 7 and I hope you have gone through the videos that were mostly based on distributional semantics and word embeddings. So we will see some questions related to that. So the first question is like which of the following algorithm can learn the word representations directly from the word co-occurrence matrix and assume that the raw text corpus is not given. Then you have to choose which all options apply. This can be multiple option, correct? Like more than one answer can also be correct for this question. Here I hope PCA, you know, it refers to the principal component analysis. SVD is singular value decomposition. GLOVE is this one of the word embedding models, and CBOW stand for the continuous bag of words. This is one of the models we have seen in the lectures also. This is one of the variants of word to vec model. So the answer to this question can be MCQ, multiple option correct. Please attempt this question. We'll discuss in 2 minutes. I hope the question is clear to you. Someone has put the answer. B is correct and A. Okay. Please give it a try and put your answers in the chat box. What about option C? Okay, shall I discuss the answer? Please unmute if you're still solving it. Let me know, otherwise I shall discuss. Am I audible? Am I audible?
Yes, ma'am.
Yes.
Okay. So, so these two, if you see, this PC and SVD, these are dimensionality reduction techniques. Means, what do we mean by dimensionality reduction? Let's say the originally it was present in 500k dimensions, and you want to reduce it to just 100 dimension or a 300 dimension vector. So in that case, you can apply these two techniques, where PCA refers to the principal component analysis and SVD refers to the singular value decomposition. And because the word representations is, what is the goal of the word representations, is to learn a low dimensional representation that we also call as the word embedding. So these two techniques can be easily applied, A and B. What about continuous bag of the words? Here, as we have seen in the lectures, it does require a raw text corpus to learn the data. Why does it require? Because only from the data it will learn and analyze, because there you require this, no? The size of the vocabulary, that is V, right? What is vocabulary? Please unmute and tell.
A set of all the words.
Set of all the yes, set of all the words, or you can see the unique words. In Python, if you are doing set, it will by itself or drop the duplicates. So all the unique words that are there in the vocabulary, it will require the access to that. Why? How can we infer that? Because you remember from your lecture, we need to learn these two parameters, w1 and w2, right? These are the parameters that you learn when you are training this model of yours. Now, what is continuous bag of words? What I am given and what I am to find. So in the continuous bag of the words, I am given the context words, right? What are the context words? Surrounding words. And I am to predict the center word. So in this case, I need the access to the raw text corpus. So, and for the glove, as we know, we already have the pre-trained co-occurrence matrix. If you remember the formula as discussed in the lecture, this is the PEIJ, that is the co-occurrence probability that we already know. So in this case, you do not require a raw text corpus. So the correct answers are option A, B, and C. For D, you will require a raw text corpus. So I hope the explanation is clear.
Yes, ma'am.
Okay. Yes, A, B, C combined is the answer. Not only option A, not only B, but combinedly A, B, and C. Okay. So moving to the next question. Question 2. So here you have been given this value or the number of the documents CW1. That is, consider it as your first document. So the count CW1 refers to the count of the first document. And similarly, CW2 refers to the count of the second document. Consider CW1 comma W2 the count in which the let's say you had some document and there this is the count of the word first word, how many times it is appearing in the document, and how many times CW2 refers how many times the second word appears in the document, and then this refers W1 and W2 how many times they both appear in the document, like where both the words have appeared. Let's say there were 50 documents in which first word appeared, 100 documents in which the second word appeared, but in all combinedly word 1 and word 2, let's say this was the word cat, this was the word dog, so it appeared in first 50 documents, it appeared in 100 documents, but there were some documents in which cat and dog both appeared, that is given as 5 here. Total number of documents has been given to be 10 to the power 5 in this case. And you are to find PMI. What is PMI? Can anyone tell?
Pointwise mutual.
Point-wise mutual information, ma'am.
Yes, correct. So you are just to apply this formula here and get the value. Please solve and let me know the answer in the chat box. Give it a try once. And here NAT means the natural unit of information. You must be wondering what is this unit that is given here? That is natural unit of information. Now please give a try to this question. Just apply the formula for PMI and get the value. Let me know the answer in the chat box. I'll give you 3 minutes to solve this question. Please rate this option as 4.605 and this is 6.908. Little typo here, and this is 2.2 nats. That is 2 natural units of information. Please read the options as such. There was a little typo in the options. Anyone able to get the answer? Please put your answer in the chat box once you have solved it. Let me see if there is any response. 2 nats. Sandeep says 6.64. Okay, let us discuss it now. So here we have been given the count of first word as 50, count of the word 2 as 100, and the number of documents in which both the words appear together is 5. Total number of documents is given to be 10 to the power 5, right? Yes. So now we have to apply the formula of PMI, that is point wise mutual information. So what is the formula for PMI? That is ln, natural log I will take, probability of both the words appearing together upon probability of the first word into the probability of the second word. Am I given the probability here? I'm not given the probability here, but I can find it. How will I find the probability of the first word? That is count of W1 upon total number of documents. That is 50 upon 10 to the power 5. And how will you find the probability for the second word? That would be 100 upon 10 to the power 5. And probability of both W1 and W2 would be this count of W1, W2 divided by n. That would be 5 by 10 to the power 5. So just plug in these values here. What we will get? Probability of W1 and W2, that is this value. That is 5 upon 10 to the power 5 upon, in the denominator what we will get? This thing, probability of W1 upon probability of W1, that is the first one, 50 upon 10 to the power 5 into what this, please read it as in power. I don't know if it is clear enough or not. So read this as being in power, and this value will be 5 upon 10 to the power 5. So if you solve this, and don't forget that we had the natural logarithm outside. So if you solve it, 110 to the power 5 cuts out. So this will value comes out to be 10 to the power 5, 5 into 10 to the power 5, 50 into 5. So this you cut out. And
Ma'am, the second term should be 100, not 5.
yes, yes, it should be 100. This is count of the second word, right? So, and already we have 50 over here in the denominator. and we are to take the natural log of it. So let me just rewrite it. So this is 100. So now this becomes, so seeing from the previous slide, it becomes ln of 10 to the power 5 upon me 10 into 100, that is ln of 100, that is nearly 4.605 nats, natural unit of information. This is the natural logarithm that you have to take. So the answer is option C. I hope it is clear to all how we found this. Here it was given us the count of the two words. We calculated the probability. How we calculated the probability? That is count upon n, the count of that particular word in count of the documents in which that word is appearing upon total number of documents. And what does the formula of the point-wise mutual information states? You have to take the natural log of probability of the two words occurring together upon, in the denominator you will have the product of their individual probabilities. Just solve, plug in the values and get the answer as 4.605. That is your option C. Is it clear to all?
Ma'am, I have a doubt.
Yes.
Ma'am, instead the material gives log instead of using LAN.
Sorry?
Ma'am, the formula gives us log of count, log base to count of W1, W2 into N divided by count of W1 into count of W2.
But if you
It's
see
similar.
in the options, it does not correspond to them if you try to solve by taking log. It will come out, I think, by taking this natural log.
Okay, so when I applied log, I get 2 nuts. So that only I put it in chat box. 2 nuts.
Okay. I think you go with this natural log.
Yes, ma'am. Okay, okay. Thank you.
Any other question? Someone was asking here. Please tell your doubt. Okay. So any other questions? Okay, assuming that there is no question. So this is the question for finding the KL divergence between two probability distributions. The random variable is given as x here, and read this symbol as z belongs to. Okay, read this symbol as z belongs to x belongs to, like this. X belongs to positive integers, which means that x can go from 1 till infinity. And then you have been given these two probabilities and you have to calculate the KL divergence between P and Q. This is the probability that has been given, and just apply the formula for the KL divergence that we have seen in the lecture. Plug in the values and let me know what answer you are getting. Then we will solve it. Please attempt this question and put your answers in the chat box. Can anyone tell what do we use KL divergence for? Please unmute and tell. What do we use scale divergence for? I hope you have gone through the lecture. This is there covered in one of the lectures. I hope you know this. Shall I tell the formula and then you will solve? Because I cannot see any answer in the chat box. Give it a try once. So KL divergence is used to find how much one probability distribution differs from another probability distribution. Is it symmetric or asymmetric? Are you solving? Please unmute and let me know. Okay. Okay, okay. Then please solve. I will wait. If needed, you apply the formula for the GP series and AGP series. Geometric progression and arithmetic geometric progression. What is the formula for the geometric progression? A upon 1 minus R. A is the first term and R is the common ratio. You might need to use this, so use it wherever needed. And let me know what answer you are getting. I've already given you the hint. So anybody able to solve? Anybody able to solve? Okay. Do you need more time to solve this, or I'll discuss? Okay, let's wait for 2 minutes more. C. Okay, great. The correct answer is option C, as Sandeep has already solved. Let me discuss the solution with you. So we are to find the KL divergence, and we have been given that the probability x equals to x is probability that capital X takes the value as x is 1 upon 2 to the power x when the probability distribution follows this, and in case of the second probability distribution the value is 2 upon 3 to the power x. So what is the formula for the KL divergence theorem is like this, that is you will take the summation over x. What is the probability of x following this probability distribution? Whatever comes here first, that you will write here, followed by the sigma term, and in them you will have this logarithmic value p of x upon q of x. This is asymmetric function. Why was I asking whether it's symmetric or asymmetric? Because if the formula were like this, q over p, then it would have been summation x qx into log of qx over px. So whatever is there written here on the left hand side of this pipe symbol, that will come before the log and in the numerator of the log. Okay, I hope it is clear. So based on our question, we are to use this first formula. Just you have to remember that KL divergence is an asymmetric function. It will give the different answer in both the cases. So now from the question, we have been given that x belongs to 1 to infinity. Why? Because it was given that x belongs to the positive integers. Positive integers lie in this range. So now we are solving this. Sigma x equals to 1 till infinity. What is the probability that capital X takes the value from the distribution P, that is 1 over 2 to the power x log of Px, that is 1 upon 2 to the power x, Qx, that is 2 upon 3 to the power x. So I know that log of A by B, I can either write it as log A minus log of B, or I'll first simply solve it here. X equals to 1 till infinity, 1 upon 2 to the power x into log of 1 upon 2 to the power x into 3 to the power x upon 2. So what does this value come out as? Next time, please join in the beginning. Like if you join in the mid of the session and we are in discussing the middle of the question, it becomes a little difficult to follow or to reiterate the process. So please make sure to join in the beginning of the session. It will be helpful for me as well to know how many people are getting the solution or not. So following from the previous line, x equals to 1 till infinity, 1 upon 2, then it becomes log of 1 by 2 into, I have clubbed this term together here, this 1 by 2, and in this I am having 3 power x and 2 power x, this I will combine. So this will become 3 by 2 to the power x. So this is in the power we have x. So we know that the formula log of AB becomes log A plus log B. This is the logarithmic property that we are going to use in this case. That is x equals to 1 to infinity 1 by 2 log of 1 by 2. This px is a multiplication to the whole. Please don't forget this term. So this will be 1 by 2 log of 1 by 2 plus 1 by 2 log of 3 by 2 to the power x. And this whole term is contained in this sigma symbol. So also we know that log of a to the power b becomes as b log a. Whatever is in the power will come in front of this log. That's what I have written it over here. So how will this become? X by 2 log of 3 by 2, and we are going to take the summation here, x equals to 1 till infinity. And here what was the term like? I think what you can do, little typo here. What you can do, we know that this log of 1 by 2 is going to be a constant, right? So we take it outside. Then this becomes x equals to 1 till infinity 1 by 2. And here it becomes x by 2 log of 3 by 2. This is the term that we are getting now. And here what you will do, x equals to 1 till infinity, log you took outside 1 by 2.
Ma'am, I think you should take 1 by 2 outside, not log of 1 by 2.
Wait.
1 by 2 is common in both the terms.
1 by 2 if we take outside, just wait. One over 2 to the power x. This is log of 1 over, this should be 1 over 2 to the power x also was here now. This I missed out. 1 by 2 to the power x, and inside we got log of 1 by 2 into 3 by 2 to the power x. Okay. Now we have to look into this 1 by 2 to the power x. So this is 1 by 2 to the power x log of 1 by 2 plus, because this was being multiplied to the whole, 1 by 2 to the power x into log of 3 by 2 to the power x. So this will become like, here now what I will take out common, this log of 1 by 2 is a constant that I will take out. Now what I am left with, x equals to 1 to infinity 1 upon 2 to the power x. And what does the other term becomes? That becomes as x equals to 1 till infinity log of, this log of 3 by 2 to the power x. Now if this x comes in to the front, as I said, log of a to the power b becomes b log a, right? So what happened here now, I can this term, I'll rewrite it for better understanding. What it becomes here in the middle is like this, x upon 2 to the power x into log of 3 by 2. This log of 3 by 2 I know is a constant. So what I will do, this is some little maths involved here. So this log of 3 by 2 will come outside, and inside what I am left with, x upon 2 to the power x, and here this is my first term, this is my second term. So I'll write it more clearly here. What does this become? From the previous slide, log of 1 by 2 sigma x equals to 1 till infinity. What was the term inside? 1 upon 2 to the power x. And what is the second term? Log of 3 by 2 sigma x equals to 1 till infinity x upon 2 to the power x. So if you see here, this is a GP series. How? Here, if you put the first term as 1, then it will become 1 by 2, and it is going till infinity. I know the formula for the GP series infinite, that is a upon 1 minus r, where a is my first term and r is the common ratio. So this becomes 1 by 2 upon 1 minus 1 by 2, that is 1 by 2 over 1 by 2. This comes out as 1. Okay, so then this formula reduces to, this term itself, it reduces to log of 1 by 2. This entire term came out to be 1. And here you will apply the formula for AGP series. Why I say so AGP series? If you put the first term as x equals to 1, then it will become 1 by 2. But if you put x as 2, then this will be 2 over 2 to the power 2. That will be again 1 by 2. And if you put 3, then it will be 3 upon 2 to the power 3. Okay. Take it as 2 over 2 to the power 2. And take it as 2 to the power of 0 upon 2 to the power of 1. And if you solve this, you have to solve this AGP series. What value you will get out from here is 2. So your, your final term reduces to 2 into log of 3 by 2. So that is your option C. You just have to apply the formula of AGP series, that is arithmetic progression. arithmetic geometric progression over here, solve this and get the answer. I hope the formula is clear. It's just here we applied initially the formula for KL divergence, and rest all is the maths, log and AGP series. Is it clear to all? Is it clear to all?
Yes.
Let me know in case anyone is having any doubt.
Ma'am, can you tell once again log second term reduced
Yeah,
log?
you just apply this AGP series here, no? We studied back in class 12th.
Yes, how will you conclude two?
You apply this formula, no?
Okay, 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 ma'am. Okay, ma'am.
Like
Thanks.
see, this series do you want me to
Yes,
solve
yes,
it?
yes, ma'am. I understood. Understood.
See, 1 by 2, then this becomes 2 over 2 to the power 2. This becomes 3 over 2 to the power 3. And like this you will solve. And you multiply this entire series by some number. Let's say you multiply it by 2. You take the difference of the two series and then again you apply this GP formula. A upon 1 minus R. You will be able to solve it.
Ma'am,
Okay?
thank you. Thank you. Thank you.
Yeah. So let us cover one more question. This is directly based on the, what do we say, word embeddings concept. We saw it in the lecture. Please try to answer this question. This is related to the analogy tasks. Given king is to queen as man is to woman, and as man is to what? So in the question they call it as A, this they call it as B, man they call it as C, and this question mark they call as D. So what formula do we apply in the case of word vectors that they have expressed in terms of these four relations, and whether we will do the dictionary lookup or what? So please attempt this and let me know the answer in the chat box. What is the general formula to compute the word vectors that you just have to apply your knowledge here in this case? Let's say I'll give you the hint. This is my n-dimensional space. Here I am given the word vector A. This is my word vector B, and somewhere here is the word vector C. And the word vector D lies here. So from reaching from these three, how will I obtain this word vector D? That analogy, that in terms of this equation you have to tell. And it is a single option correct. Let me know your answers in the chat box. This is very well discussed in the lecture. Yes. So please tell, will we do the dictionary lookup or not? You also have to take this thing into account. The formula is correct that we will do VC plus VB minus VA, but whether we do the dictionary lookup or not, this also you have to take into account. So please all of you put your answers in the chat box. We will discuss in 2 minutes. I want you to give a try. For your doubt early on how to solve the arithmetic or geometric progression, I am giving you one link. You can refer to this link later. As of now, please attempt this question. Option A. Are you sure it should be option A? I want you to look into this aspect, whether we do the dictionary lookup or not.
One question then, for dictionary lookup,
Mm-hmm.
do we So basically, we get one vector which is vector d,
Yes.
and for a dictionary lookup, that basically means we take a look at vector d and select the exact match that is there earlier, right? Or
No.
no? So then it says no, we don't do it then.
Yes, that's why I told you to emphasize on this concept of dictionary lookup. Dictionary lookup is like whether this word maps, like once you got this vector, now what does this refer to?
Okay, so I think then we take the most similar word in the
Yes,
dictionary.
yes, that is exactly the concept. I'll discuss it. Just let others also give an attempt.
Okay.
Okay, I'll discuss in just 1 minute. But I hope you got your doubt cleared.
Yes, ma'am.
Yeah. Okay. Great. Okay, so let me discuss this point. So, let's say this is my n dimensional space and I am having vectors like A, B, C here, and I am to find what would be the vector dimension representation for D. And let's say this is what I find out. Actually, in the corpus, D is given like this. In the actual corpus, to me, D is given like this, and this is my D that I have predicted. So given given the relations of this sort, A is to B, and then we are to find what is the relation with D. So let's say it was like king is to queen. As king is related to queen, so man is related to what? Can you tell me what should come here? What should come here?
Woman.
Exactly, woman. Why? Because we are referring to the male and the female relations here. Okay. So here, let's say now they are giving me what, how do I find? So I will find what is the offset here. Queen minus king, like how is it related? How queen is related to the king? If you remember in the word embeddings, what does these dimensions represent? Whether it's masculine, whether it's royal, whether it's feminine, whether it's power and stuff like that. That is how we constitute the d dimension vector, no? So here, first of all, you will find the difference, that is VB minus VA, that we call as the offset. How, what is the difference between these two? What is the relation I am trying to analyze between queen and the king? Then I will add it with another word that is given to me, that is man. Now, let's say I got some vector representation here, but I was to look what were now in case of this DP, I will be getting certain values here for every dimension. Let's say for royalty, I got some value, for feminine, I got some value. But now I have also to know which word in my entire corpus is most closely related to D. So for that, do I do the dictionary lookup or what should I do? I try to find what is the most similar word. I will not do the dictionary lookup. I will try to find what is the most similar word to my predicted vector dp. So, and how do we find the most similar word? Mostly we use the concept of cosine similarity between A and B is given by like A dot B over squared norm of A squared norm of B. This is my formula for finding the cosine similarity. But if you see all the options, it is given dictionary lookup for VD, dictionary lookup for VD. That is something that we do not do over here. We do the similarity check. That too using the cosine similarity. Okay, so the answer will be here option D. Is it clear to all? In the lecture, it is covered under the concept of word embeddings. Word embeddings are nothing but getting the d dimension vector representation for every word. And these d dimensions can be royalty, play, fruit, something like that. Like these are some predefined concepts or classes. And at every point in this vector, you will get a number. Let's say for the king, you will be getting for royalty the value is 0.99, and let's say this category was feminine. So is king a feminine? Can king be qualified as feminine? So here the value will be very, very low, 0.0001, something like this. So we will be getting the probability value corresponding to every dimension. That's why we compute the similarity check here to know whether the vector that I have predicted. So let's say in this case, king is to queen, as man is to what? Here wife could come, woman could come, girl could come. But if we see the most closely related word for this, I should be having the maximum probability. And that value I can find using the cosine similarity. I will choose this then. Is it clear to all? Okay, great. So this is all for today. You can I will upload the YouTube this today's discussion on this YouTube channel, and in case you have any doubt, feel free to write to me at this email ID. I'll put it in the chat box. If you have any doubt in this assignment or the previous assignments, you just let me know. Okay. So that's all for today's session. Thank you all for joining. In case you have any doubts, please stay back and ask. I hope you are solving the assignments. The assignment for the current run will be most closely related to the questions that I am discussing. Any doubts? Please feel free to ask. Okay, then thank you all. Thank you for joining today's session.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.
Thank you.